In this video, I'm going to go over iperf 2.014's enhanced reports. Um, and if you run it without the enhanced report option, you're just going to get the same output as if it were iperf 2.05, which is old version that we've been improving upon. So this version, if you can see with iperf minus v, is 2.0.14a, compiled as of January 10th, 2020. So if you run iperf, so on the top here, just there's one computer, and this is my client, and the bottom is the terminal to the second computer. And if you do an ifconfig, you can see that the second computer, which will be the server, has the destination address of 192.168.1.10, and the client's address is given via DHCP, and that is where was that? This address 192.168.1.87. These are also 10 gigabit networks, and there's a 10 gigabit switch without much traffic. Another thing to notice that these computers have is GPS disciplined oven controlled oscillators, so the timing of the real-time clock for some of the more advanced features is pretty good. It would be good if data centers provided this to the virtual machines, and it sort of seems like something that should be default by my book, is that we should have GPS clocks, all the real-time clocks synced to the GPS atomic clock. It just makes things a lot easier. But anyway, to show you what happens, so if you run iperf just standard without the any special options, it's going to look just like iperf 2.05, and you're not going to understand, okay, what's the advantage of upgrading really. And there are performance advantages to upgrading, but some of the other advantages are the ability to get more output. So here's with no interval reporting, you do get the connect time. The idea with the minus e was that if we didn't use minus e, we wanted to be script compatible for automation test scripts that we're using iperf. We didn't want to break those scripts. So to get the advanced reporting or the enhanced reporting, use minus e, and what you'll see is a little bit more information. It's actually better to do it with sampling or with the I interval, because the I interval will give you data in flight. So like the congestion window R2T at the end isn't about meaningful. But anyways, to give you an idea of the new fields versus without E, you're going to get a write and a write error and a retry and a congestion window and a net power metric. And on the server, looks like I got a bug on the other one I need to fix. Let's put minus E, and let's see what it does. Versus, yeah, this is just a bug in the code. I'll fix that. I've been working on the code lately. Okay, yeah, I'll fix that. But the final output number is wrong, but I'll fix that. But anyways, what I care about are the fact that the new fields are there, which is the reads and the read histogram. So I'll go through that in a minute. Okay, and then for UDP, you're gonna get. So let's do, before I go to UDP, let's do with I interval reporting, so you get an idea of how that works with the interval reporting. Oh shoot, I need to give it a value. Sorry about that. Let's try that again, I1, and let's try this again with I1. I needed that one first, so let's do this. And then there. Okay, that should get it. All right, so now you get a sampled congestion window and a sampled RTT, as well as the net power and the retry. The retry is not a sampled value; it's actual value. These come from the kernel level statistics on the socket, and iperf queries those to get those. And then the congestion window and RTT are sampled, and this is for 1.5 megabytes, and this is about 1 millisecond, 1,087 microseconds for the RTT. On the receive side, on the server side, what you're going to see is a histogram. It's basically, I'm going to take the read buffer size and break it up by 8. So the first histogram is 0 to 16K, 16K to 32K, 32 to 48, all the way up to 128K. The separator is the colon. So of that, you can get an idea of how many reads per bin. So for the first one, it says between a byte and 16K bytes, there's 568 reads returned with that. All keep on going, and then the largest one is 128k minus 16, whatever that is. So 225 were there. So if you change your read side with the minus L, the bin size will change. I can do that just for grins if you want to see it. So if I do minus, since I say it's 128k, so let's do 258, 256k, and see. So now I reset is 256 instead of 128, and we should notice the bin size are changing. Yes, the bin size doubled, 32k, and you'll see it. So that's something to notice. So I don't give the option to set the number of bins. It's just defaulting to number 8. Okay, so that's it for pretty much TCP. But the other thing is for UDP, particularly if you have the clocks, real-time clocks synchronized to the atomic clock or synchronized to each other, is what really counts. However you do that, it's kind of nice because what you get now with the advanced reporting is latency numbers, end-to-end latency, and so that gives you per packet latency value. So with minus E, and also on the client, you're getting the write and write errors in the packet per second calculation. So on this one, the average latency is 154 microseconds, 92 is the minimum, and this particular sample interval in the maximum, and the net power calculation, which is going over in another video. So let's just for grins, let's bump it up from 1 megabit streams. This is a 10 gig link, so let's push it up a little bit and see what happens. And let me see. So even though you're going to gigabit, latency is actually still pretty reasonable. It's actually better. So the driver's probably aggregating things to do this. The gigabit Ethernet driver is probably liking it that things are coming faster because it's able to aggregate and do things in bunches and get overall better latency. So that's pretty cool. But anyways, in Wi-Fi, you'll see a lot of variation in latency. I don't know what these drops are. Anyways, okay, so that's it. So if you're using iperf 2, if you want the advanced features, the take home is use minus E. Otherwise, you won't get the new outputs. And this is for all the tests. This is what I showed here was just a basic TCP UDP, but there's other tests that will demonstrate, and they all require the minus E to get the more advanced output. Okay, give that a try and let me know how it goes.